Welcome to Tabo Eminent Channel. The three-body problem is a famous problem in physics and astronomy that deals with predicting the motion of three celestial bodies, like stars, planets, or moons, that interact with each other through gravity. The three-body problem is one of the most fascinating and complex puzzles in science. It all starts with a seemingly simple idea. Imagine three objects in space, say, the Sun, Earth, and Moon, all pulling on each other through gravity. You might expect that with enough math, scientists could predict exactly how these bodies will move over time. Thanks for watching. Request you to subscribe the channel. That works fine when there are only two objects. For example, we can predict Earth's orbit around the Sun with incredible precision. But once a third body enters the picture, everything changes. The gravitational interactions become so tangled and interdependent that no general formula exists to predict their motions exactly over time. Even a tiny change in one object's position or velocity can lead to vastly different outcomes, a hallmark of chaotic systems. For centuries, mathematicians tried to solve the three-body problem using classical physics, but they always hit a wall. In fact, it wasn't until the late 1800s that the mathematician Henri Poincaré proved that a simple, universal solution doesn't exist. His work laid the foundation for chaos theory and showed that the motion of three interacting celestial bodies is inherently unpredictable in the long term. Today, scientists use powerful computers and numerical simulations to approximate their paths, and these methods are good enough for planning space missions or understanding planetary systems. Yet, the mystery and elegance of the three-body problem continue to inspire both scientific inquiry and imagination, so much so that it even became the centerpiece of a science fiction novel, The Three-Body Problem by Lou Sixon, where an alien civilization is trapped on a planet suffering from unpredictable orbital chaos due to its unstable three-star system. The real-world version of the problem reminds us how something that seems simple on the surface can reveal an entire universe of complexity beneath. The story of the three-body problem is not just a tale of math and physics, it's a deep reflection on the limits of human understanding. For centuries, astronomers and thinkers believed the universe was like a great cosmic clock, orderly, predictable, and governed by fixed laws. This belief was bolstered by Isaac Newton's law of universal gravitation, which beautifully explained how two bodies, like the Earth and the Sun, interact. Encouraged by that success, scientists assumed that adding just one more body, like the Moon, would be a small step forward. But that step turned out to be a leap into chaos. As soon as a third gravitationally interacting object was added, the entire system became unpredictable. No elegant equation could capture the dance of three bodies tugging at one another in space, changing each other's paths in ways that ripple endlessly through time. This mystery captured the imagination of some of history's greatest minds. Mathematicians like Euler and Lagrange found special cases where solutions were possible, such as when the bodies formed perfect equilateral triangles in motion. But these were rare exceptions, not the rule. It wasn't until Henri Poincaré's groundbreaking work in the late 1800s that the true nature of the problem was revealed. The three-body problem was chaotic, sensitive to initial conditions, and unsolvable in the general case. His insights helped give birth to modern chaos theory, a branch of mathematics that shows how deterministic systems can still behave unpredictably. Today, the problem isn't just a mathematical curiosity, it's a cornerstone of astrophysics, used to model complex systems like star clusters, planetary orbits, and even the motion of spacecraft. Yet, it also lives on in popular culture. Lou Sixon's The Three-Body Problem novel introduces a fictional alien world struggling with the same issue, its civilization rising and falling in tune with the chaotic orbits of its three suns. The three-body problem, in this sense, is more than just a scientific challenge, it's a symbol of the unknown, the unpredictable, and the beautiful complexity that lies at the heart of the universe. As science advanced into the 20th and 21st centuries, the three-body problem became a symbol of the growing tension between human curiosity and the complexity of nature. In an age when we send probes to the edges of the solar system and land rovers on Mars, it's humbling to realize that a problem as simple as predicting the movement of three celestial bodies still defies a complete, universal solution. It's not for lack of effort. Scientists have thrown the most powerful computers at it, running simulations that calculate millions of possible outcomes. These numerical solutions can be astonishingly accurate for specific cases and time spans, allowing us to chart the paths of moons, planets, and even spacecraft. Yet, the underlying truth remains. Even the tiniest variation in the starting conditions can spiral into wildly different outcomes, making long-term predictions nearly impossible. This sensitivity to initial conditions is the essence of chaos, and it reveals a universe that is not cold and mechanical, but alive with surprises. This idea has philosophical weight too. The three-body problem challenges the classical notion that if we just knew everything about a system, we could predict its future perfectly. It forces us to accept uncertainty not as a flaw in our science, but as a natural part of how the universe operates. In that way, it's not just a scientific problem, it's a metaphor for life itself. We often try to plan and predict, to map our futures like astronomers charting stars, but the unexpected always finds a way in. That same unpredictability is what makes the universe fascinating. From the graceful curves of planetary orbits to the chaos of galaxies colliding, the three-body problem sits at the heart of it all, a puzzle with no perfect answer, but endless possibilities. And perhaps, that's the real story, not one of failure to solve, but of the human drive to understand even when the answers aren't simple. The allure of the three-body problem lies not just in its difficulty, but in how it bridges science, philosophy, and even art. For those who study the stars, it represents a frontier where order meets disorder, where the precision of Newton's laws is tested by the wild, entangled dance of three gravitational bodies. Picture three stars locked in a mutual embrace, each pulling on the others, their paths looping, curving, flinging one another into new trajectories. A cosmic ballet that can last for millions of years or end in sudden, violent ejection. These systems exist in the universe, and they are breathtaking to behold through telescopes. Yet for scientists, simulating their behavior is like trying to predict the path of leaves in a storm. No two scenarios are ever quite the same, and outcomes can be as varied as the stars themselves. But perhaps the most compelling part of the three-body problem is how it has captured the imagination far beyond the world of science. Artists, writers, and philosophers have all drawn inspiration from it. In Lou Cixoun's The Three-Body Problem, humanity encounters an alien civilization plagued by the very same issue, its world caught in the gravitational chaos of three suns. The unpredictable nature of their environment becomes a metaphor for instability, survival, and hope in the face of uncertainty. It's a story that resonates with us because it mirrors our own world, where certainty is often an illusion, and control is something we constantly seek but rarely possess.